Hello, this is the Somewhere on Earth podcast. I'm Gareth Mitchell, and it is Tuesday, the 25th of June, 2024, and we're here in London. All our voices are from London today. In fact, we're all around the table, which is rather nice, so none of these problems with lines going down or anything like that. We are right here to bring you this podcast. And one of us round the table is expert commentator Ghislaine Boddington. Hello, Ghislaine, again, 2 weeks running.
I know, Gareth, lovely. Yes, to see you again. And yep, I'm with you today to speak to these two amazing live interviews. You're right, it is really lovely, all four of us at the table.
Yeah, and we're really teasing that, aren't they? There's these two people there, kind of these ghostly presences that we've not introduced yet, but you will hear from them, and they're not ghosts, don't worry, folks. So, Ghislaine, what do you have any gossip for us this week?
Well, I want to do a little push today,
plug?
a little plug, that's it, a little
All
plug.
right.
It's a link to the STEMettes, where I'm a trustee for the STEMettes, which is an organisation, London-based charity that works all over Britain and sometimes internationally, helping girls and non-binary women stay within the science, technology, engineering, maths sector, and making it fun, making it accessible, making it, the STEM push, so the STEMettes. Well, we've just produced a white paper, and this white paper is online. It's stemets.org white paper. You can download it and read it, and you can add a quote to it and pass it on to people. And we do need help to do this, because it's about getting a more diverse female and non-binary representation in the GCSE and A-level curriculum. It's UK, but this is probably all over the world, where at the moment these young women, when they're doing science, technology, engineering or maths, they only learn about one female scientist, and they learn about 14 male scientists. They have none mathematical, 3 men, no women in engineering, 2 men, and none in computer science, and 1 man. I think it's 20 to 1. And there's only 1 woman who is mentioned in the GCSE, actually, curriculum, and that's Marie Curie, fair enough, but we're trying to get that changed to make a more equitable place for women to be referenced properly, historically and present day scientists, technologists, engineers and mathematicians.
Hence the white paper.
Hence the white paper, because we need these role models. We need this in the statutory curriculum. And this probably is the same in many countries. Can't believe this in 2024, can you?
Awesome. Ghislaine, thank you very much for that. Let's jump in. And coming up today, there's a definite AI theme this week. Well, when isn't there an AI theme, I guess? But anyway, I have 2 remarkable stories for you this week about machine learning's different facets. In one case, potentially helping to diagnose cancer, giving doctors better early warnings in this most time-critical group of diseases. In the other case, how AI can help tackle loneliness, as much of the world finds itself in a so-called loneliness epidemic. That's all right here on the Somewhere on Earth podcast. First then, AI and cancer. Now, for one thing, cancer isn't just a single disease. It's a whole family of diseases. And to a greater or lesser extent, cancers have a genetic component. So looking for disruptions to our DNA, our genetic code, well, that seems a logical idea when we're trying to diagnose cancer. The trouble is, it's not quite as easy as saying, oh, look, this gene is affected. That must mean it's this kind of a disease. At first sight, then, the way that cancers affect our DNA, it can seem almost random, actually. It's only when you look at enough human genomes and enough cases of disease that you begin to notice patterns. And when I say enough, I mean literally billions of individual data points, sifting through them to see which, if any, might be significant. Now, that's an area in which many researchers are rolling out the AI. And Dr. Shamith Samara-jiwa of Imperial College London is no different. He's the lead author on a new paper on the early detection and diagnosis of cancer through disease-specific DNA methylation patterns. Don't panic, folks. We'll explain that to you, what it all means. And it's great to have you in the studio. Welcome along, Shamith.
Hi.
So just getting some of the genetics sorted first. In my very simplistic way, I often think of cancer as being to do with mutations. When there's some kind of, you think about the genetic code, those 4 letters, the DNA, the A, the G, the C, and the T, and there's a typo, a mutation, in other words. But when you talk about methylation, that's something different, isn't it?
Yeah. So normally people look at genetic mutations or aberrations where you have damage to the chromosomes, but epigenetic changes where environmental information gets temporarily activated, like that can imprint the cell in a way that modifies gene function. So that these enzymes that can methylate the C, letter C, the cytosine molecules in DNA, and it adds little methyl group onto the molecules. It normally does these additions to regions that have CG pairs, and about 80% of the genome can be methylated this way.
Okay.
Yeah.
So I suppose if I can simplify it very wildly, because I'm going to move on to the AI in a minute, it's almost, if you think about mutations as being like a typo, if you like a letter's missing. Can I just put it to you that this methylation effect is not so much a typo, but as if the text has been smudged slightly?
Yeah, it's kind of like temporary whiteout of letters,
Yeah, okay.
so that it's almost like a mutation, but it's reversible. So when the environmental messages stop or change, they can come off.
Right. So it doesn't change the initial letters in the same way that a mutation might. Okay, I get that.
They get chemically modified.
Yeah. And you can say it can be temporary. And when you're talking about environmental factors, you just mean if somebody's smoking, for instance, or if it's exposure to the sun or many of the other things that we know are cancer risks.
Yeah.
And this effect
There's lots
happen.
of these things that can affect the epigenome.
And it's hugely complicated. So let's move swiftly on to the AI, which gets me slightly back into my comfort zone as well. As you can tell, folks, I'm no expert in the genetic side of things here. But what even I can understand is that you're embarking on a massive pattern recognition exercise, aren't you? Because these methylations, these disruptions in a way to the way that the DNA presents itself, they come in patterns. And if you look at enough of them, you can begin to associate a particular pattern, like a signature, as it were, maybe with a particular kind of cancer. Can I go that far?
Yeah.
Thank goodness. Right.
We're getting there.
We're getting there.
All of us. Yeah.
This pattern recognition is incredibly complicated. I don't know if you can, but is there any way you can quantify it? In my introduction, I just fudged it and said there are literally billions of possible patterns. But is that the kind of thing we're getting into here?
So there are sequencing methods that detect these methylation changes in an entire genome. And if you sequence enough tumors, you'll find the patterns that are specific to each cancer type. And the important thing is these changes happen really early in cancer before you see symptoms. And so if you can detect these, most cancers can be treated to have positive outcome.
So the changes are there. And I suppose the good news story here is, in fact, it's a completely good news story, because the good news initially is that these changes are there. We have the technology to detect them. Maybe the not so good news is it's very difficult to pull insights out from these changes. But now we're back onto the good news again. With the kind of technology, the AI that we have, the power that it has, you're now able to get meaningful insights from these kinds of disruptions to the DNA in cancers.
Yeah.
Early on as well, crucially.
That's important, I think, because the earlier you detect these things, the better the outcome for patients.
Of course, it's crucial. It's such a time-critical disease or set of diseases. So, Glenn, what do you make of this? You know, this, especially that early detection, it really is essential, isn't it?
Now that feels incredible, the possibility for early detection and the possibility, therefore, for people to possibly change the environmental issue and move backwards, like you say, for it to recover, or probably the wrong word, recover. But so the complexity of this means that actually at this point you are working with a large-scale computing, huge computing setups. I was wondering about where you can, I know this isn't right now, but where can you see this going in the future into a more mass use?
So once the models are trained, they don't require that much computing. The patient sample, like the biopsy stage, to prepare and sequence DNA, you require some computation, but it's nothing massive. Like it's most sequencing centers can handle that kind of, modern hospitals can handle that kind of throughput.
I was thinking about this in relationship to biomarkers. Does it come under this head of biomarker? If, for example, we were at a stage where I could go to hospital and your system could say, yes, you've got the beginnings of your very early prediction, does that become a biomarker for me that can be recognised and put into my record?
Eventually, it can be used in that way, but you'd need to do a lot more work to get to that stage, like explore these methylation changes a lot more. People already use a small number of these in sequencing panels to diagnose cancer. What we've done is we've cataloged all the methylation changes genome-wide, not just single chromosome, not single marker or single gene, but all the changes in each cancer type genome-wide. So I think that gives us more information in the future to come up with like proper biomarkers.
Yeah, so and that's crucial, isn't it? Because with the AI, I suppose it's tempting to focus on the algorithm, but what you're saying is yes, but we need the data as well, and a big part of what you've done here is getting the data.
We didn't generate all the data sets. We used large cancer genome studies from various consortia, and we generated one of the studies. But the majority of data was out there.
Also, a really big important thing that you're doing here that I was struck by in your paper is that you're looking at the inner workings of the algorithm itself. Because we so often hear that AI is great, but it's so often a black box, isn't it? We don't really have any idea of how it's going from A and ending up with B or C, or goodness knows where it's going to end up. Tell me a bit about then this opening up the algorithm so you can see what it's doing.
We haven't used any specialist techniques, right? We were keen on using methods that were interpretable and explainable so that the features or the methylation positions that it figures out can be used to understand the biology. And so the method we used is called a XGBoost model, like gradient boost, boosted tree classification model. And it identified all the important methylation features in each cancer type, and then we fed that to a deep neural network, which improved the classification. So it's very simple. It's nothing complicated.
Yeah, I love the way you said, "Oh, it's really simple," and I'm sure it is the essence of it. But just the way you're putting it there as well. We'll stay with you, Shamith, but I do want to bring in Tony Prescott. He's our next guest. He's going to come in and talk about his book. But rather handily, Tony, you're a professor of cognitive robotics at the University of Sheffield in England. And even more handily, you've just written a book about the psychology of AI. So you know a bit about this stuff. And I know you haven't read Shamith's paper and you're not across his research. But what are you picking up in general just about this whole conversation, for instance, around the algorithms, being able to look inside the black box and understand more about it and all the other stuff you've been?
Stay with us. We'll be right back.
You love listening to podcasts, but have you ever thought about starting your own podcast? Maybe you want to build a brand, grow your business, or are looking for an excuse to talk about your favorite hobby. Whatever your reason for making a podcast, Buzzsprout is the place to start. Since 2009, Buzzsprout has helped over 300,000 people launch their own podcasts. Buzzsprout walks you step by step through the whole process and will give you powerful tools to start, grow, and monetize your podcast. Ready to get started? Click the link in the show notes to get our free step-by-step guide to starting your podcast today.
Yeah, good evening, everybody. And that's a fantastic study and really quite exciting. And I think the power of AI to unlock this kind of data. So you've got this huge mountain of medical data, of which this is just a tiny fraction. And just by using AI, we can extract signal out of what's probably an extremely noisy data set. So, in the old days, a PhD student might have pored over this data for 3 years and come across one or two things. And with this technology, you can now, in an afternoon, find out, once you've set it up, you run the algorithm and it goes across the whole genome. It's super powerful. So it's really going to transform how we do medicine and how we do diagnosis. And it just really shows the power for good of artificial intelligence.
Shamith, you were nodding there.
No, I agree.
Yeah.
Yeah.
Okay. Glenn, a final thought from you on this?
I agree too. And I think what I'm fascinated by what you said, Shamith, about working with a consortium, and everybody pooling, and it's like a crowd science scenario. I think that I've only just begun to realise the last couple of years how much that's happening with biomarkers, with biobanks across the world, where there's a lot of them in many different countries, and I realise now that they are sharing and working together and sharing of other scientists, and it's all been poured over in this kind of crazy, huge pool where actually, yes, things are moving very fast, and that's for the good of us all. It really is AI for good. Yes.
Well, there we'll leave it at Shamith for now, but hopefully you will stay back for the podcast extra for our subscribers. So Shamith can sit and relax now and listen to us talk about Tony's books. But thank you very much for coming in and telling us what you have done so far. And so that's Dr. Shamith Samara-jiwa of Imperial College. So we're going to talk a little bit now about loneliness with Tony, because I suppose, ironically, in a way, one thing you can say for yourself if you are lonely is that you're actually far from alone. In fact, we are in the midst of a loneliness pandemic, as some people have put it. But Tony argues in his new book that artificial intelligence is increasingly capable of supporting us with social interaction and breaking that cycle of low self-esteem and social isolation that often comes with loneliness. So those revelations and more come in the forthcoming book, The Psychology of Artificial Intelligence. So should we pick up on that, Tony, just on loneliness and what you have to say about it in the book, and indeed the way that AI can help that cycle that does have for so many people, that it drags them down into loneliness?
I mean, the strange thing about loneliness is we think of it as a psychological phenomenon, but it's also a real health issue. It's we are mammals and we are social animals, and to be isolated actually impacts our health. So I think the World Health Organization has described loneliness as being as bad for your health as smoking 15 cigarettes a day. And if you look in the UK, nearly half of us describe ourselves as sometimes lonely. And I think 7%, which is nearly 4 million people, say they're lonely all the time. So for those people, there's a really negative health impact of this social isolation. So it's not like being hungry or thirsty, and that, if you're hungry, you eat, and if you don't eat, you would starve to death. With loneliness, there is a kind of biological need for a company. If you don't have it, you won't thrive, but you'll get by. And the question is, are there things that we can be doing? Obviously, we could do what we should do and can do to scaffold people with human companionship. So what extra could we do with AI? And that's what I talk about in the book.
Yeah. Would this be chatbots, for instance, or are there lots of other ways that AI can help?
Yeah, chatbots is a good example, and obviously with the latest large language models, chatbots have really come a long way, because it used to be that they would just parrot back what you just said to them and they wouldn't have any memory. But the chatbots now can remember the whole conversation or back to a previous conversation, and they can offer advice. And these large language models have read hundreds of thousands of books, including quite a lot of books about loneliness and therapy and help. So they actually could give you some psychological support, but they don't have to be doing that necessarily to be helpful, because it's just, for a lot of people, just the social companionship of something that listens and responds.
Yeah, but my mum has a virtual assistant. In fact, I'm not on the BBC anymore, so I can say it's Alexa. But other brands are available. And she loves Alexa, she really does. And I get a bit creeped out sometimes by all of these voice assistants and about, the data and what have you. But Mum's not going to have a thing. She lives on her own, and she says, if, say, she's unplugged Alexa to take her upstairs, which I think is also rather endearing, because sometimes she prefers Alexa to be in the bedroom to wake her up in the morning, and sometimes she wants her downstairs. So anyway, but if she's in a room where Alexa isn't, she kind of misses her,
Yeah.
So there's something in it,
And there is this myth that older people don't like technology, but I think it's completely untrue. The number of older people that we talk to are really excited about this technology. And we might say a bit about robots, but I think, there is a real interest from people that live alone in having social robots, maybe ones that are more pet-like, but you could have a conversation with.
Yeah, there you go. No, Anya says in my headphones, it says her mum loves Alexa, switches the lights on and off.
I
My
think
mum
it's
likes that.
seriously
Just
well.
lounge off.
These
Yes.
voice aid assistants are very helpful in senior citizens' homes, and I know definitely, and also obviously Facebook and video conferencing, FaceTime or video catch-ups on families has been really, really important. Yeah, I think one of the things that worries me though is you were mentioning about the feedback from a chat box around, say, more therapy-based feedback. I do know a number of colleagues who are therapists in various different ways who are absolutely freaking out about this harvesting.
But isn't
of
that because they're worried
multiple-
about their jobs, though?
No, I think it's about the mass harvesting of multiple articles and books, say on loneliness, to give this kind of slightly, what is it, AI feedback, which isn't necessarily as sound as being with another human, So,
I mean, there's benefits and risks, and there's obviously things like intellectual property rights. I'm kind of more on the side of benefits. I understand the risks, but another way to look at it, not to be critical of your therapy friends, is that this is in a way democratizing access to that knowledge. A lot of it was produced by universities. I know there are some books published, that were copyright, but there's a lot of stuff that scientists like me put out into the public domain, and these have been harvested by AI. And so, yes, I think maybe we should be more careful about creating the data sets that used to train the large language models. But that doesn't mean to say that we should throw the baby out with the bathwater. And
no,
say
not
that
at all.
the
I just
idea's
think
not
it's not
good.
so much about the harvesting I'm talking. It's more about the kind of way it's put together and comes out and whether it's the right advice. Yeah.
Well, I think it's about doing things which are complementary. So I think that what you don't get is access to your therapist at 1 o'clock in the morning. They probably won't be very happy if you phone them up and say, I'm desperate for a chat. Whereas the AI is always there, happy to listen to your story, even if you've told them the same story multiple times. And so I think there are different uses. And I wouldn't want to replace the human therapist. And I think absolutely human contact is super important. And one of the ideas is that with this artificial companion, you get the social scaffolding. So the loop you were talking about, the spiral downwards of self-esteem, which causes people that are feeling lonely and social isolated, makes them feel, I can't talk to anybody. And so when there's an opportunity for social contact, they let it pass by because they've got zero self-confidence. So perhaps with the AI chatbot, you could practice your social skills, scaffold them a bit. It could give you some positive feedback, help you feel better about yourself. And that might help you then build those human contacts.
Although we do have now AI girlfriends where millions of men just have these virtual agent girlfriends.
And that's another of the risks, that we...
So that's a desocialization.
So we go down the path of...
They can talk to AI girlfriend, but they can't talk to a real girl.
I agree. No, it's
in some cases.
There's definitely challenges. I'm not sort of saying
no.
Let's all go down the route.
Exactly. But you brought Gordon with you, haven't you?
Yeah. So Gordon is an animal-like robot. He's part of a species of robot, if you like, which we call Miro, and it looks a bit like. People say it's a puppy or it's a rabbit, somewhere in between the two. It's got a tail, it's got ears, it's got eyes, which are cameras, ears, which are microphones. It can move around and look at you. This version, with its current software, doesn't talk, but it does make animal-like noises.
Oh, well, this is radio. Can we give that a try?
We can turn Gordon on
Miro.
And see what he does.
Gordon, sit.
So he is fully autonomous. So I'm going to be starting him via Bluetooth controller on my phone. But then what he does after that is up to him, or up to it, I should say. It's not gendered. So hopefully, here we go. So you probably can hear the motors. So you can probably hear Gordon making animal-like sounds. He has a sound generator, which is modelled on the mammalian larynx. So he makes the right kinds of sounds for an animal of this size. So
fantastic.
This was built by a colleague of mine at Sheffield called Roger Moore. It's a simulation of the larynx, which is generating that sound. Okay.
Yeah, I was interested in the sound. Yeah, because it sounds almost human-like or childlike, the sound, rather than. And I'm not dissing it, but you're saying the point is that the range of the sound is what you'd expect for like a physiological entity of this size.
Yeah, we wanted to make a robot that was animal-like, but wasn't any specific animal, because people have expectations about puppies and rabbits and so on. So we wanted people to respond to it, and Ghislaine is
Come here then.
So he's actually able to move, but I've turned off his motors.
But he's
so
looking at me, and
he
he knows I'm here. He's come round to look at me.
That is, it was really quite striking. Yes, Ghislaine talks to Gordon. Oh, and now I'm talking now. Gordon's listening to me and actually pivoting his ears up towards me, and now looking a bit taken back. Probably because I'm kind of talking about Gordon, but not really to him. And
he's totally not listening to what you're saying.
Well, welcome to my life.
He's paying attention to anything that makes sound or moves visually that's within his visual field. So if he was able to spin around the table, but I've disabled that so he can't, then he would now look at me.
Yeah.
But if you start talking again, he'll look at you again.
Okay. Right. So if I start talking, sure enough, you can see, he's peering at me through one of his eyes and now the other. How endearing.
He has tactile sensors.
Oh, right.
And when you...
So you're kind of stroking
I'm
Gordon
stroking
now.
them.
Yeah.
And you can see he's got lights in his body.
Yes. He's got a kind of translucent body, hasn't he? And then through that body we can see lights.
You can see these stripes, which are kind of like ribs.
Yes.
And those are the touch sensors. So he's detecting, and Ghislaine's also
he's detecting you, and the point being, as you, I know you're a roboticist, scientist, but as a user, say a child, for instance, they're getting feedback as well, because they can see Gordon responding not just through his movements and his eye gestures, but also what's going on in his body.
He's wiggling his tail now.
The lights have gone green, and he's wiggling his tail.
Yeah,
so,
he's very happy.
So you get positive feedback. So we've done a lot of outreach with children, and there have been some studies with children, and it has an effect of calming people, as do some other robots like this. So you spend a few minutes interacting with Gordon, and children, when we've done this at public events, children that are really quite hyper because they're in an exciting place have come, and they've often sat down and cuddled the robot for 10-15 minutes, and it's had a calming effect, which has really pleased the parents.
Right.
And so that's the basis for thinking it might be useful for a kind of animal-assisted therapy. At the university, where we have a lot of students with social anxiety, one of the ideas is that they would come to the counselling services for therapy, and they'd meet a therapist, but also this would be complementary. And perhaps if they were too nervous and shy to talk to a therapist, they could still get a positive experience by meeting something very non-threatening like this robot.
You just want to take it home now, wouldn't you? Yeah,
you would.
Can I have it, please, to take home so that I don't have so much loneliness?
Yeah. No, I can see I can see the function of it and the serious research purpose behind it. So on one level, really cute, good fun in a podcast studio, but really the basis of some important research. So we've only got about 3 or 4 minutes to do the whole of your book, and it's quite a long book and very deep it goes too, but it is the psychology of AI. So let's do the basic one first then. Why did you want to, because it's such a massive topic to take on, the psychology of AI, so why did you want to write the book?
My background is that I'm a psychologist, trained in psychology originally, then I did AI, and then in the last 20 years I've done robots, but really using robots to understand minds. So I write programs that go inside the robot and control it. So this one is controlled by a very simple model of the brain. The core theme of the book is what is intelligence, and what is human intelligence, and what would it mean to have a machine that was intelligent, and have we got there yet? So that's what the book is about for most of the 7 chapters.
Yeah, because you finish with artificial general intelligence, don't you? Which is this move to something that we might think is, well, you tell me, is it intelligent? So I don't want to spoil the book too much, but
my answer is that AI is intelligent, but it's not intelligent in all the ways that humans are, and there are aspects of intelligence that AI hasn't captured yet.
Because one brilliant example that you give that I think really helped make me understand that argument is you say that an LLM, for instance, you can have a conversation with a large language model chatbot about the Arctic monkeys, for instance, and this thing, and it will be actually a meaningful, intelligent, in inverted commas, conversation with a chatbot AI about this band, and yet it's never listened to the Arctic monkeys. It's incapable of engaging with it musically. And I thought that was a very good example to say what it can do, but what it can't do.
And there's actually two sides to understanding, and I think this is where people get confused. So when we understand language, we understand the relationship between the words. And that's what large language models do, because they've absorbed all this literature and millions of web pages.
It's pattern recognition again.
It is, yeah. But and what's remarkable and surprised many people, including me, is how effectively these large language models have built a model of the world, if you like, in order to understand language. Because you don't understand language the way that they do without understanding something about the world. So they've had to build a model, and your models are the same, in order to
and you're talking back to Shamith, by the way, not my models.
Yes. In order to explain the patterns in cancer, they've had to understand something about DNA and cells, and when you dig into that neural network, you will find there's some understanding in there. When you say pattern recognition, that's kind of making it sound quite simple. There's a really sophisticated analysis that is going on inside that deep network. And your own brain is a whole bunch of deep networks that are networked together. So the book is also about what a brain is. And a brain is, probably 200,000 deep networks. That's what your cortex is, that are all talking together and networking. So we are getting close in our technology to building something that's very brain-like.
Wow. Ghislaine, you have loads of thoughts on this, don't you? This whole area.
No, I think it's completely fascinating, and I'm really interested in how you've been working. I know you'll work a number of years, with the robotic body, the robot, as a representation of, in a way, our brains and ourselves, And as you know, my work's more with the avatar body, and but they're both digital interfaces of different types, so where we can reflect ourselves and work with and get mirrors back. So we are at a very interesting point with the AI assistant, with the robotic assistant, etc., coming into our mundane lives, making maybe a bit more room for creative thinking for us, getting rid of some of the more robotic things that we have to do ourselves, and opening up space, I hope, for a bit more critical reflection and solution creation by working alongside and with robots and with avatars, etc., and AI, the plus of it, to enable our lives to be better, to actually sort out some of those issues, like the loneliness issue that you're dealing with so clearly on this.
Yeah, I absolutely agree with you about using these technologies as a kind of mirror to ourselves, so they kind of reflect back at us something about ourselves. I was saying about what large language models understand. They understand the relationship between words, but they don't understand the relationship of words to the world. So these are all just patterns. With a robot, you can start to relate words to the world. So the robot can start to understand what a chair is, what a table is, what sort of things you can do with the ball. You could push it, you could move it. So AIs don't yet have that knowledge, but they could do through robots. So it's that grounding of your language in the world that's the difference between a large language model and even a small child. A child might have a vocabulary of 200 words, but they know what those words mean. They know what cup is. And they know you can grasp a cup, you can drink from it, and so on. A large language model can talk all about cups and grasping and drinking, but it has no knowledge of what that means.
I think that's really great explanation, actually.
Is it basically impossible for an AI to have anything like what we might consider to be intelligence, as long as it is unembodied, if it doesn't have sensors and other ways of interacting with the world? And I love the way you mentioned the child at the end, who might only have a vocabulary of 200 words, but that child exists in the world, and that's the difference, is it?
Yeah, it's difficult to know with AI because, of course, you can pass knowledge from one AI to another effortlessly and seamlessly, whereas we all have to discover the world ourselves for the first time. And until we get language, we're on our own in terms of understanding the world, and then our parents can start to help us by teaching us. But with AIs, you could pass the knowledge on. So it may not be that you need that much robotic embodiment before the AIs will have this kind of understanding of the physical world. We still to find out.
Yes, that's to come. Yeah, it's an exciting time, actually.
And also to come, for those of you who subscribe, we will carry on talking about this in the podcast subscription extra. If you're not a subscriber, I know it's really annoying that you think that you're being left out and so on, but don't worry, you got a fair crack of it in this version of the podcast. It's just that we give you just a little bit more in the subscription extra as well. But thank you very much to you, Tony, for coming in, and to you, Shamith. We'll talk to you on the other side, as we say here in podcasting, and you, Galan, as well. 2 weeks running. Lucky us.
Yes.
Good on you.
See you soon.
See you soon. Thank you very much. The sound and audio today is from Dylan Burton here at Lanson's Team Farner. The production manager is Liz Toohey. The producer and editor is Anya Likterovich. And I'm some kind of embodied humanoid, not particularly intelligent at the best of times, called Gareth. Thanks for listening. Bye-bye.